And now it's time for the latest exciting episode of Doz's Television Workshop.
Like you ever doubted it. Hello and welcome back to Doz's Television Workshop. It's that Panasonic from last week. Something's turned up as I was editing the video, which has caused me to have a bit of an introspective here, and the microphone picked up something early on in the video which I couldn't hear, and I suspect it's because there was no sound being emitted. It was an electromagnetic thing. Now if you watch that video, you'll notice when I was using the line transformer tester that the mains adapter was arcing, and while I couldn't hear that, the lav mic was picking up all that interference. And it had also picked up some interference from earlier on in the video. And I just want to show you that. Okay, so I'm about 10 minutes into the video here. And this is the bit where I just switch out the lamp limiter. I wonder if our lamp is just limiting too many volts. Let's bring the lamp out and see what happens. What? So that's the first thing. First of all, I think that's the sound starting up in the set itself. Now, we didn't have that after the fault developed. So I'm thinking at this point, actually the set is trying to run. But I'm thinking the sound is probably being supplied by a line-derived supply. So that is a power supply derived from the line stage. So basically there's a rectifier off the line stage that's then driving the audio somewhere on the chassis. And that's coming up and working. Now let's just continue. And it all goes quiet again, which might be as the tube heats up and puts some more load on the line stage or whatever. Strong whistle. And I think that's line whistle at this point. Doesn't sound very happy at that. Well, that's at full, well, that's 200 volts. If you listen carefully and we have a lot of smoke. I'm going to stop and just rewind that last section there. Listen again. That's 200 volts. Can you hear that pop, 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 pop on the soundtrack? I think that's the transformer failing internally and creating a bit of interference, which is being picked up by the lav. Just the wiring on the lav mic actually receiving the interference, the electromagnetic interference, and popping and crackling, because that sound wasn't in the workshop as I shot this scene. Right, well, we need to investigate that, won't we? Good, because if it had just come up and run, it would have been a very short video, wouldn't it? If only I'd known then that it was going to be an absolute nightmare. But there we go. So our power supply, I reckon, started up, and then the instant our line transformer got going, it collapsed and failed spectacularly. So there you go. Right, what are we going to do about it? Right, I've made a purchase. This may be utterly frivolous, I don't know yet, but let's open it and see what delights I've got in here. There's a lot of that sort of air packaging involved here. Yes, the very thing. You can probably tell what it is by now. Oh, it is a Picture Master HD, no less. Just call me Adrian's Digital Basement. Now you see what happened was, as I went away on holiday and I thought about that set a little bit more, and then I thought, well, Adrian did it to a Commodore monitor. let's see if we can't do it to our TV set. It would give us a useful little thing. The only thing that concerns me is when Adrian did it with his monitor, he retrofitted into that Commodore monitor a much more recent CRT, a more recent tube, something from the noughties, I would think, whereas our tube was made in 1978. So, will this drive a more older style of tube? There's only one way to find out, isn't there? Well, there it is. Yeah. And the beauty of this also is, because Adrian had to implement a voltage doubler in the primary of his power supply bits and pieces, because he's 120 volts. Of course, here in the UK, we have the benefit of 240 volts, so I haven't got to worry about any of that. It does concern me. The other thing was, my goodness, it's flimsy, isn't it? The other thing that does concern me about it is the chassis type is listed as being able to run between a 14 and a 21-inch tube, and I think our tubes are 13. What's an inch between friends? Well, we're going to find out, aren't we? So, yeah. The main concern I really have is if this tube base connector here is going to be anything like the tube base connector on our Panasonic, because I suspect not. We may have to do some advanced bodgery to get it anything like working. Oh, I've got spare wiring. What's that for? Speakers, perhaps? Yeah, I can imagine that's for the speaker wiring. So let's go through. Let's see what we've got. We've got an infrared receiver. We've got the front panel. That's clever. It's only got 2 wires. I suspect that's a voltage divider. Yeah, you can see the resistors. So every time you press a button, it reads a different voltage out, and they read it into an A to D and use it to define which button's been pressed. Trick I've done on microcontrollers before now. We've got an AV input, presumably front mounted as if. We've got sockets on the rear. No SCART, which is a pity. There's a Toshiba jungle chip. What do we got? An 8895 CSN G7GG9, no less. Jungle IC, that's the decoder, the remote, the microprocessor, everything, a little tuner. So, yeah. Are we going to get anywhere with this, or am I simply wasting my time? Degauss is there, mains input goes in there. Have we got a switch? No, we don't have a switch, but it's okay because there'll be one in the set we can reuse. This is our width, this is our scan yoke here. Presumably, yeah, we could do with some instructions, couldn't we, really? That would have been nice, but hey. That one's going to be one side of the line. We're going to have the other side of the line and the frame. We should be able to work that out. Excellent. Right, let's get the set back in here, get it in bits, and then see what our chances are of grafting this thing together and making any semblance of it. Where do the speakers plug in? Oh, down the front there, look. That's where they're going to live. We're only going to have one speaker, so I may leave one disconnected. It's probably the best bet. So there it is. Yeah. Right, let's get on with it. Right, hello darkness, my old friend. Right, let's get that anode cap out of the way. I'm not just going to trust that actually. Where's my discharging probe? There it is. Because it may have had some EHT on it since we last put it back together. You never know. These things do sit tight and then charge themselves back up again. No, nothing in there at all. That's okay. Right. That's him. Right. So, what I'm going to do, I'm just going to disconnect from the power supply there. Because our mains is coming in here. We've got some gubbins going on over there, which I shall need to disseminate, but that can get unplugged because we're never going to use that. That can get unplugged there. That goes off to the front panel somewhere. It's to the tuner, I suspect. We'll have to come up with some cunning plan to mount the controls if this works. That's nothing to do with us. That's sort of sound and stuff goes up there. Okay. And I don't know what that is, but that's connecting there as well. That should be everything, except for, of course, the tube base itself. Now, okay, so that's dag earth. That's the yoke, clearly. This tube base looks very different. That's our there's focus, and this will be our chroma drives. You can see our output transistors for the three guns there, the red, green and blue, are on this board, whereas on that one they'll be on that main... Oh no, they are on the neck board. Okay, right, well that I may need to rob parts from. This lot is now scrap. Oh, what's that? Something else connected. Okay, let's sack that off. Right, you, my friend, are finished. Oh. Right, and welcome to the game. Okay, the march of technology. Look at that. Okay, so what I intend to do is sort of lash everything together in the vain hope we can make something work and at least get a picture. That tube base is nothing like. So we either get data for this picture tube and then reverse engineer this part to work out what goes where, or we may even end up, because this, you'll notice there's a lot of different solder positions on this neck board here, so we may be able to remove the base from our other tube base, our other neck board, fit it, and then maybe we get lucky and it works out. Maybe we don't. Yeah, so that, however, does look like our ground position. That is our ground position. There's one wire I can connect already, look. Fabulous. Yeah, so there's one. Right, let us get the remote control sensor out of the way. Scan is going to be an exciting game to want to play. Yeah, so let us, what am I going to do first? I think first things first, let's get the discharge probe out of the way. Drop it down the front for now. First things first, yeah, let's deal with this neck board, I think. So clearly the focus is going into this block here, which is going to be removed. This is screen here, screen voltage. So, or A1 sometimes, same thing. So let me just desolder that from there for now. I know exactly where it goes. I'm also going to remove the focus anode connector if I can. That should just flip out from there. There we go. So I can just desolder that focus connector. Right. So, what have we got on the old neck board? Where did I put the old neck board? It is here. So clearly that lead there is our focus. I don't know where our first anode comes in. That's going to be on that orange lead there. Here we go, screen. So let's just cut that out of the way. Screen A1, all the same voltage. So that's listed as coming in on that pin there, which on this board is pin 2. Is there a place where... Oh, it's all listed on here. That's really helpful. Cathode G1 not connected, which is connected, interestingly. Oh, it's all grounded. Okay, so we've got ground not connected, G1 not connected, G1 heater, red cathode not connected, 4 another G1, BK3, okay, BK blue cathode, green cathode, yeah, okay. So half the pins on that base aren't actually used. So if we got a base pattern on here that looks similar to that, that would work. So we've got focus up there. So we've got other bases that come around here. I think the thing I'm going to have to do anyway is to remove this base from this neck board. I'm going to remove that base from that neck board. And then see if we've got slots that line up and make sense. Right, on with the desoldering tool. Well, I'm just going to put some fresh solder on this tube base. It'll make it easier to get off. Sounds like my tool's blocking up already. Oh, that's not being successful, is it? Right, we shall come back and repair that later. But meanwhile, I shall carry on with some very expensive desoldering braid. It was a bigger struggle than it should have been. Okay, so is there going to be anything like the right number of pins? Now they sort of show a base going in like that. Oh. One going in there, look. That pin there, that pin there, there. I'm not so sure. Focus round that way. So that's cathode red, which would be there. And our red cathode's miles out of it. That base has got to come off anyway, so let's just take that off and have a look. Because what's the worst that can happen? I've no doubt that we're going to end up with some bodge wires or maybe something else to make this work. Right, finally. So I'm just going to unsolder these other positions, just clear the solder from them, and then we'll look to see if we've got any possibility of mounting our tube base in there, and if the wiring is anything like correct. I somehow doubt it. I think we're going to end up sort of mounting this base on wiring and maybe moving it around a bit, but well, we've got a chance. Right, do any of those line up with any of this whatsoever? You can see they've made a universal sort of neck board with many different sort of base patterns in there to, well, hang on a minute, whoa. That one seems to be almost perfect, except for there's nowhere to connect this ground pin. But that's okay. We could make something up. But does any of that bear any resemblance to the correct pins on the correct connections? So let's just sort of fit that in there for a second and see how far out we are with anything else. Right, okay. So now that wasn't it. Wow, hang on a minute. We may have other options. What's that? Well, there are many chances of finding something here, I think. That one's not going to work. That's sort of got a big space in it, as if it was going to take our ground pin. Oh, yeah, there we go. No. So we've got at least a physical footprint that fits our socket. Would you look at that? So let's compare that to our actual board. So that was our ground pin. Ground, correct. That pin there is G1. No, it's not. It's the blue cathode. Blue cathode. Pin 4 is... Okay, that might be G1. That's not connected here. Pin 5 is not connected. On here, on this board, it's pin 4. Hang on. So we've got ground, blue cathode, first grid. Okay, ground, blue cathode, correct. First grid not connected. 5, they say, is not connected, which is ground here. So that's G1, 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 yeah. So that pin needs to be G1. This pin can go to ground if it wishes, which it does. The next pin round after that is Y5, whatever that is. Heater. So, ground. That could well be heater because it goes straight out to the board. That one should be heater. Pin 7, heater, which goes to ground, correct. Pin 8, which is red cathode. Comes round here. Red cathode. Good Lord. So that one, pin 9 is G1 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that's our screen voltage. Okay. All is not lost. Yes, this is screen here. So that leaves us 3. 1, 2, 3. 1, 2, 3. I've miscounted. No, that is screen. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. I'm counting from the wrong end, aren't I? So ground. 1, 2, 3, 4, 5, 6, 7, 8 is screen. Ground. 1, 2, 3, 4, 5, 6, 7, 8 is screen. This could well work. That one there is red cathode. No, it can't be. Okay, let's count round again. Let's count from the other end. So 13 is G1, which is grounded. Yep. That one there. Cathode. Green cathode. Green cathode. That one there, which then connects to red cathode. Green cathode. G1. Red cathode. 11 is not connected. And we've got our screen, correct. Struggle to make that connection again, but we'll manage. Then we've got that one there. That is our red cathode. Which I don't think it is. It connects to this trace here, which is also common up there. I think that's a ground. It is. So I think if we switch 2 wires round, we should be good to go. I'm just going to draw this out and screw my loaf over a cup of tea and make sure I'm right. But I'm thinking we've catered for a 1978 Panasonic tube. Let's go and draw a diagram. Right, I've drawn out the base. Pin 1 is focus. That's the wire on the base. In fact, the numbers are written on the base here. So yeah, I've gone and made a list of the Panasonic connections and the Chinese connections. And we're all good until we get to pin 4, which is G1 on the Pana, and it's not connected on the Chinese. We're good again all the way down to pin 11, which is red cathode on the Chinese, and it's the first grid on the Pana. So I think we cut the red cathode connection and take that to ground. We should be good. Green cathode, and 13 is ground as well. Now the first grid voltage, I suspect on the Panasonic they're holding it slightly below ground, which is why they're not grounded, and I suspect on the Chinese chassis it's at ground, and then they drive the cathodes appropriately to get the right vision modulation and modulation on the tube. I could be wrong. I am just going to check the difference between G1 and ground on this board, actually. In fact, we could do that now, couldn't we? So I'll just move my diagram out the way for a moment. And so yeah, so what is the difference? So G1, oh, it comes off the bottom of the screen control. So yeah, they've earthed the bottom of the high voltage screen back to the grid. So it goes via a couple of resistors there, and actually back down to ground anyway. So that's what they've done, is they've just used that to, in effect, how to describe this? So the ground it's slightly above ground, which allows them to drive the tube a little bit easier with the available electronics of the time. So we're not interested in electronics of the time anymore, as long as our tube is compatible, which it seems to be more or less. I've just got to make that change. I've got a ground pin 4, which is 2, 3, 4, that one there. And then cut the red cathode trace, which I did work out a minute ago. Anyway, let's just do that. I'm going to solder the base in properly first, and then we'll go from there. I shall get the universal workshop vise and use that to hold everything down while my shaky hands solder up the tube base. Okay, so that's our tube base in. So I need to connect pin 4 to ground. I can do that there. Let me just get a little piece of wire. I can solder onto that unpopulated pad there. Okay, and the other pin we had to change was the red cathode, which needs to be grounded, and that's pin 11. So, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our red cathode is on pin 8, 2, 3, 4, 5, 6, 7, 8, which is connected there. So yeah, if I snip that trace there, and then connect that to that there, then goes back to ground. That would work well. Right, so let me just get a scalpel and disconnect that red cathode that comes from there. cut it, I'm going to leave quite a big gap in there. There are some quite exciting voltages on here, so we don't want anything jumping across and making a mess of our lives. So I'm just going to heat that track up. We should find it peels away quite nicely. There we go. Okay. So you can see I've removed that piece of track there, and then all I've got to do is short those two together there. What would be a nice way to do that? I think if I just scrape a bit of the solder resist off. Where's my fiberglass pencil? And then just stick a blob of solder on it would do us well, I think. Some nice shiny copper there. So I can just get a blob in there. That will be brilliant. If I can't, I'll add a piece of wire. But oh, straight away. Okay. Well, that could be that. The next thing to address is, I suppose, our scan coils. So yeah, let's have a look at that. And then I think we may be sort of in a position for an initial switch on. Tube base is going to go on at a jaunty angle, isn't it? Okay, let's make our focus connection. That's an important thing to make. Can I get that connector apart on this base? Oh, don't tell me I've got to desolder it again. Surely not. I don't think I do. Let me just get a screwdriver, see if I can tweak that open there. That might be permanently fitted, you know. I think it is. Well, maybe not. Let's see if we can tweak that apart. I could, of course, splice the focus wire. It's a really nasty thing to want to do because it's quite a high voltage and we don't want it splashing about the place and spoiling our day. But I'm not sure that just comes apart. And I need to remember this plastic is getting on in its years. And do I want to force anything? I think that's all moulded in one piece. I think that is. So I'm going to have to splice that. That is unpleasant but needs must. So yeah, let's just do that. I'm going to choose a piece of heat shrink and I'm going to backfill it with RTV. If you cast your minds back, if you were a follower of the channel back when I did the Pi 169, we actually had a splice in the HT lead, and that was okay. So yeah, let me just do that. And in fact, if you look at the original Panasonic connector, it's only got a bit of plastic around it. It's not a massive deal. So focus voltage is probably in the region of somewhere between 5,000 and 7,000 volts. So yeah. Just tin these up. There we go. I need to get a piece of heat shrink. Okay. That's a super long piece, that'll be just fine. So let's just get rid of that for a moment. Okay, so that can be over there. I'm just going to put some RTV in there and then shrink that down. Bear with me one moment while I prepare the RTV. I've got my splices in there. What I'm going to do is I'm going to aim that up there. I'm just going to shrink that end down, just at that very last end there, just to give me something to pour the sealant against. So a bit of shrinkage going on there. That's good. So that's not good actually. What's the temperature set to? 100 degrees. Yeah, that's not enough. That's more like it. The Panasonic side of the cable is slightly thicker, so that's going to leave me some more room to get my sealant, which is in this syringe. I know somebody will ask in the comments, so this is a Dow 734 RTV. I'm just going to squeeze as much in there as I can possibly do, and then seal it, heat shrink the rest of it up, and that should make a good insulated joint. Let's just hope it makes its way down. Yeah, it is. Oh, that's good. Look at that. You can see it travelling down the tube perfectly. Excellent. Okay, let me just extract that. Hot the other end up. In fact, I'll hot the whole tube up. It will ooze and make a mess, but it's going to be a good tight seal in there. So we should have good, you know, electrical properties, and also, yeah, it's not going to let any wet in. It's not going to fall apart. As you can see, the RTV is dribbling out all over my bench and making a horrible mess. But that will make a terrifically insulated joint. So there we go. I'm just going to get a bit of paper towel and clean that up. There. Right, I'm just going to leave that a few minutes to go tacky, and then we'll come back and have a look at how this chassis does its scanning. Let's get on it. Right, our RTV's not fully cured, but it's not making a sticky mess everywhere, so that's good enough for me. Next thing to worry about is our scan. So, yeah. So these are the 4 wires here that go to the scan coils. This red one here appears to be on a tap, and I suspect that's a width sort of setting. We'll look at that in a minute. We'll leave it on the middle one for now. I suspect we may need to adjust that. There is sort of software adjustments for width, height, etc. Drive to the tube, so that's good. We can deal with all the little idiosyncrasies of that. Ah, yes. That is our screen, isn't it? That needs to connect back in there. Let's just do that before we go mad. So that goes to that pin there on our tube base, and then that's our tube base complete. So let me just solder that into position. Lovely. Tube base complete. Level up. Right. Okay. So we've got some unknowns with regards to the to which wire's which here. Obviously that red one is A line, but then we've got a black and a white lead towards that end of this plug here, and we've got a blue one. I suspect the blue might be our other line, but we need to confirm that. And I don't have a diagram for this thing or any information whatsoever. So yeah, let's just have a look at that connector, see where we go. So that's our tap from the line stage. Interesting. That is going... Oh, it also goes to there. Okay, that's fine. Now the second one down appears to be going via that capacitor there. Oh, it's not. It's an inductor. That'll probably be our line stage again. So that would indicate that our second side of our line output coil, line scan coil, sorry, is blue. But we just need to make sure that the white and the black are going somewhere near the frame stage. We don't want to mess this one up. So the white comes over here on a big fat trace, runs down there. There's a capacitor there. Difficult to say. Where's the other one go? That there runs into a capacitive network there, and that goes down. Yeah, that's going to the frame chip. So that one is definitely the frame. Let me get a multimeter and see if we can't find out where that other one actually ends up. So bit of ohms. That there does look like our line. Yeah, that's short to there, short to there. Ends up back at our line stage. So that second one is definitely line. So the other two have got to be frame. So red and blue are our line coils, which matches nicely with the red and blue on here. So that's good. So let us just... I'm going to cut this plug off. So it's not just getting the coils in the right place, but also the polarity of the coils. Obviously, if we've got the line coils connected back to front, we'll end up with a mirror image. If we end up with the frame coils back to front, we'll end up with a picture upside down, or any combination of those two things. We could end up with a picture right way up, mirror image, wrong way up, mirror image, etc., etc. So yeah, I'm just going to cut this sleeve off here, because it's going to get in my way. So let's just pull that out. All right. Okay, that's got my 4 wires nicely splayed apart. Now the way I'm going to do this is, because I don't know which way round the scan is going to be until we hopefully get a picture on the thing, what I'm going to do is I'm just going to connect these up for now. And just insulate it with a bit of tape. We'll come back and we'll make a proper job of the connection when we've got it, when we've got our polarity. We know it's correct. So right. Right, so if we went red to red, let's go yellow to white, because that's on the same side of the tube. I suspect we'll have this wrong. No, my luck. I don't even know if this tube's any good. Okay. Well, we're in a condition where we could put mains up it now and it would work. Oh, degauss coils. So clearly there's a little thermistor sort of arrangement down here. So that's going to be our degauss coils. Our degauss coil is mounted round the tube and it comes out here on this green blue there. That's not going to fit on there, is it? Unbelievable. It's got the right size plug and pitch. I've got 2 unused wires. I don't know what they do. Go up there and, oh, they're mains to a mains transformer for some reason. Okay. So anode cap on. Let me put my pad out of the way. Anode cap connected. Tube base connected, degauss coils connected, tube base, let's move that out of the way, tube base connected. Right, okay, let's move all this unwanted guff out of the way. I think I'm ready. Doesn't take long at all, really. Right, mains input. I'm just going to crocodile clip that up for now. And send it, I think. Oh, I need to put some tape on the scan coil connections just to stop them shorting out while we're checking things over. So, yeah, let's quickly do that. I shall conjure up a bit of mains lead for it. All right, bit of mains. How am I going to organise that? We need the unsafe block, which is here. We will put it on an isolated supply. So put that in there. I'm going to spin the whole chassis round so we can get it on the camera so you can see the screen. Oh, I'm going to turn the focus and the first anode all the way down, screen volts all the way down, just because we don't want some high voltages floating around. You know, let's limit the amount of damage we might be able to do. So if we turn all those voltages down, if something is going to flash over or get unpleasant, we've got a handle on that. Right, let me make some adjustments to the setup here so you can see what's going on, and we'll send it. Right, I think I am ready for the big switch on. I've got the front panel buttons here. I put some batteries in the dooky little remote that comes with it. Where is the remote receiver? Because we want to be able to see that. Yeah, it's all hooked up at the minute. That's better. Let's unhook it from the tube base. In fact, let's bring it out this side, shall we? Okay, that's the remote receiver. Camera over there is looking at the screen. I'm going to dim the workshop light slightly. There we go. And I'm just going to send it. In 5, 4, 3, 2, 1, go. I heard it degauss. I can see static on the output transformer because there's a piece of packing material has just moved towards it. And I have a CRT heaters. Do we have anything on the CRT itself? Nothing as yet. So let's bring up the screen volts and see if anything transpires. Never. The height looks too much. Width could be too much, could be too little, who knows. Let's see if we can bring the focus in a little bit. But my goodness, it's working. Wow, we can get some real sharpness there, actually. Oh, that's working really well. So far, so good. Unfortunately, I can't read Chinese, so I don't know whether that's upside down or back to front. We're going to need a video source, aren't we? let's fire up PyCow, I think, to start with, or maybe PyPatGen. PyPatGen, put it into those external AV sockets and see if we get any picture, and if it's the right way round or upside down or whatever. And then we can also set the picture geometry up and we'll go from there. Well, that's a screaming success so far, and one was sorely needed. Right, let's do that. Let's connect it up, see what happens. Well, I've made some progress. I've tuned PyPatGen in. I couldn't get it to work through the AV socket, but the AV level coming out of PyPatGen is actually a little bit low. But as you can see, that's not a bad picture. We've not got enough width, and we've got too much height. We could do with moving it over a bit, but we're in the ballpark. One thing is concerning me, and that is the brightness of the tube heaters. They are very bright, brighter than I'd like to see. So I don't know how, if at all, that supply is regulated. I suspect it's not. I suspect it's designed to be a current supply at a certain number of milliamps, and I suspect this tube is perhaps drawing a little less current, and therefore the voltage has risen and is overdriving the heaters. We're getting more power out of the heaters, which bothers me because it will shorten the life of our CRT. So what I'm just going to do is I'm going to hook some wires up to that, and we're going to measure the voltage on the heaters. I'm going to try with the RMS meter. Now, the problem is with measuring heater voltages is it's not DC, because that will be easy. It might be DC, actually. It might be DC, unlikely. It won't be 50 hertz sine wave AC, because it's probably a line derived supply. So it's going to be at our line rate, which in the UK here, that was displaying a PAL picture, is 15.625 kilohertz. And it certainly isn't sinusoidal. It'll probably be some sort of ramp waveform. So I can either use the RMS function on my fluke meter, but I don't know how accurately that's going to read, or I can use the scope. I'm going to try the meter first because it's the easiest thing to do. So I'm just going to spin the chassis back around, and we're going to measure that voltage, because if it's too high, it's going to burn those filaments out. The heater will burn out, and the tube will be no good at all, which would be a big shame, because right at the minute it's a Brahma. Incidentally, I did have to look at Adrian's digital basements in his video to work out how to switch the language, and I haven't got into the service menu yet to set any of those tweaks, because I've got no documentation with my chassis. I think Adrian got a schematic and all sorts with his, but that's just how you get with dealing with AliExpress, I suppose, isn't it? Let me just unplug that for the moment, move that out of the way, and we shall deal with the mains in a minute. But let's just familiarise ourselves with the tube base again. And oh yeah, slightly warm. Come on, out you come. So yeah, right, which was the heaters? We're pin 6 and 7, I believe. Let me just check on my diagram. Heaters 6 and 7, yeah. Okay, so pin 2, 3, 4, 5, 6 and 7. So it's those two there. And there is a current limiting resistor in there that we can change, so we can alter our heaters appropriately. Oh, 2 gash bits of wire. I'll use those bits I cut off the frame and line stage earlier. That'll do nicely. There we go. Just the job. So strip a bit off that. Just solder that on there temporarily. Let's see if the fluke gives us a sensible reading of voltage. If it does, all well and good. If it doesn't, yeah, we'll have to come up with some other plan. Using the scope, I think, because that will read RMS of funny looking waveforms, so or we can at least make an educated guess. We're aiming, I would think, for 6.3 volts, but I don't know. I might see if I can find a data sheet for the tube. 2, 3, 4, 5, 6 and 7, there and there. Okay, let's get a couple of crop clips. Right, let's hang those in free space. I've got to re-engineer the mains somewhat. And I still want to be isolated at this point because I'm not happy with everything. Okay, let me just move the lead. Oh, clutter on the bench, man. We're going to have a tidy up. It's no good. Will that reach? Just about. Okay, are we good? We are good. So, powering on. Yeah, the fluke meter is making a mess of that. It's just reading 27 volts. 27 volts. And then it's dying off. It's not DC, is it? And it's just minus 166 volts. Probably not. 27 volts. That's a lot. I don't think that's right. I think that is making a mockery of us. What I really want is some sort of averaging hot wire voltmeter, and I used to have such a thing for checking just this very thing, and it's a thing I built out of an old car fuel gauge that worked very well, and it was good for doing Phillips sets at one stage because they had an issue with underrunning heaters, and you could just short out a number of coils and bring the heaters up and make an otherwise set that you thought you had a Duff tube on very good. Right, this is going to call for the scope, I think. So, pop back in a minute and I'll set you up with scope cam. Okay, well, I was just looking for some data for the tube just to prove it was 6.3 volt heaters, and it is 6.3 volt heaters. And then I recounted the pins and realised I'd connected the fluke meter across the wrong two pins. I'd gone 7 and 8 when really we wanted 6 and 7. So having corrected that, let's have a look at what we get now. Okay, let's give the fluke a moment to do its RMS thing. And I'm showing 6 volts. I still think they're very bright, but we're in the ballpark. We're in the region of, aren't we? So I think actually I am happy with that. So yeah, the next job really is to set the thing up and see if we can get that picture geometry right. Let's get on with that. Okay, so after that minor panic on the heater voltage front, now over. Always trust in your fluke and always double check your connections. Right, powered back up. And yep, we're in. Okay, apparently to get it into service mode, we push this little magic button here. Here's my remote receiver seeing me. Let me just press menu to prove it. Oh. Yep, okay, that's working. So if I press that button, I'm probably not pressing it enough. Let me find a different tool. It's a little recessed button. There we go. Okay, so we've got our cut-off controls. I have to say the grayscale looks quite good. Yeah, okay, so we're there or thereabouts with that. So let me just push there. I want to get into the sort of geometry settings. There we go. Horizontal phase should move us left and right a bit. Vertical size, we've got far too much vertical size, so let's drop that down. Oh, there we go. That looks good. Vertical position. I'm fairly happy with that anyway. Vertical linearity, we'll come back to that in a minute. What's VSC? Don't know. Vertical blanking top, what's that doing for us? Oh, switching on and off the blanking amount. Bottom, do the same I suspect. Doesn't seem to make much difference. V center, so that will allow us to align our X in the middle. Horizontal blanking right, blank left. What we haven't got is a width. Horizontal phase should move us left and right, yeah. Got a bit of pin cushion going on there, haven't we? This curved thing going on here, which isn't right. Okay, so we haven't got a width control, but we have got that tap down here on the PCB. So I'm just going to switch off. Let me come out of menu just in case it gets upset. And it's still there. Let me pop it into standby. There we go. Okay, let me switch off. And I'm going to move the tap. I'm going to move it one position towards the rear of the set. Switch back on, see what that gives us. Now I left it in standby, does it remember that? And there we go, we're on. I can hear the high voltage come up. And has that made it worse? I think that's made it worse, hasn't it? So, okay, off again. Let's take that. I'm going to go full chat on that one, I think. Let's have a look at that. We're on. We know that's very much the wrong way. So let's go all the way to the other end. Wasn't that where I was? Okay, nearly enough width. Let's go back into that service menu. Factory.
One eternity later.
Right, well I was just going to dash out and connect up a Sky feed to the workshop. And I just thought I'd have another quick look at Adrian's video there. And clearly in his menu, he was showing NTSC trapezium and bow, they called it. And they're just not there in the PAL menu. So the PAL menu is marked up here on the screen, look, F0. If you press 1, that's 1 PAL, F1, and he had F1 NTSC showing. So what happens if I press 2? Ah, now we're getting somewhere. So it appears we do have more things for setting our geometry. So let me just file back through to our geometry settings. Let me go into the fine grid. There we go. And now we can, so is that fine width? Doesn't appear to make much difference. Parabola, here we go. Yeah, we do, and it is making a slight difference, I think. Trapezium, that's getting worse. Let's have that better. Top corner, not bothered about the corners, they look pretty good. H-bow, there we go, look. Okay, we don't have much variation in it. 6, 5, 4, 3, 2, that's worse. Then it sort of jumps back, 7, 6, 5, 4, 3, 2. So if we set that to 7, look, that's putting us in the ballpark. And H-para, now that's shifting it all the way across. So that looks reasonable. So let's go back up here. That doesn't appear to make any difference at all. But parabola, is that making a difference? Not as much as I like. Trapezium. No, that's getting worse. So let's lower that down. I'm watching these top and bottom squares to see if we can get them somewhere near. Top corner. Which top corner? Not that one. I don't think they're actually making much in the way of a difference. But H-bow is definitely making things better. And H-para, you see we can just So that's shifting it like left and right. If you look at both sides of the screen, so if I can make them at least equally bad, and then can we correct any more with that? Now that's shifting that about. Okay, let's go in parabola again. This is going to take a little bit of remembering my TV geometry settings. What is bottom corner doing for us? Is that working yet? I can't see us making any difference in anything at the bottom or the top. No. Trapezium was making a subtle difference, I thought, but yep, there we go. And that's making things worse, so we want to go all the way to the other end, I think. Well, that's the way to do this. Look, if you adjust, go between 63 and 0, you can see it start to shift about. If I go all the way up and then watch it between 1 and whatever its peak value is, there we go. See what the difference is there. I'm not seeing any difference there. Again, with this one, I don't think we get much in the way of difference. Let's go all the way down again. It just appears that range we have on the control is not quite enough to influence that H bow. I mean, it's better than it was. And that's where it seems to be best, but look, it is a compromise. Let's be honest about this. It is a compromise thing. So I wonder if there's a third menu. F3. Sub brightness. This is all OCD positions page. F4 maybe? Oh. Temperature, background, channel dark, PosTim. Logo. Or we can switch that logo off. Can we? No signal logo. No. DSP position. DVD DSP. We don't have DVD. Noise reduction. Hotel mode. 5 menu. Video IF. Really not going to mess with any of that. 6. And there's no 6th menu. So as menus are 0 through to 5 then. So it's just a shame we can't bring that parabola in any closer, but that is better. I am very happy with that. Okay, let us come out of there and hook up that TV picture and just have a look at it. Well, there you go, a picture from sky. Ignore this shadowy bit up here. As you can see, it moves with my hand, and it's because the camera is doing funny things with the exposure. But the picture to the eye is extremely bright, extremely sharp, and I'm very pleased with that. That pin cushion distortion, it could be better, especially on that shot there. You can just see the edges curving very slightly, but honestly, I don't think I'm bothered with that. I'm rather pleased. Yeah, there we go. It's a bit of a retrofit retro TV, isn't it? Yeah, all I've got to do now is make the main switch work, I think. I'm going to hide the infrared receiver in the front somewhere, mount those AV sockets on the back, and call that a win. Was it worth doing? No. The amount of hours I invested in this set, you know, fooling myself that it wasn't the output transformer to start with, plus the few hours I've spent in here today messing around with this, getting it to work, which was surprisingly easy, I must say. And the fact that the chassis cost me, I think, about 54, 52, 53 pounds, something like that, out of AliExpress. Was it worth doing? No, not really. But it's going to be quite a useful set to have in the workshop. Well, when doing my retro computers and stuff, because it is multi-standard. It will do PAL, I think CCAM and NTSC, as Adrian has proven, but I think it does CCAM as well. Not that I've ever seen a CCAM system in my life, but yeah, it opens up a few possibilities, doesn't it? So that'll do for this video, I think. Thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Cheers now. Bye. Didn't press record on the sound. You stupid boy. Let's do it again.